Ladies and gentlemen, welcome to today's webinar. We'll get started here in just a minute.
Hello, and welcome to today's AWCI Media Online Learning Series program, Prefabrication, The Future is Now, sponsored by Dryvit Systems Incorporated. I am Anne Marie Silvatelli, AWCI's Director of Education and Foundation Programs, and I will be your host for today's presentation. I am joined this afternoon by Chris William, AWCI's Director of Membership Development and Engagement, who will moderate today's program.
Thank you, Anne-Marie. Good day to everyone. Thank you for joining us. To help us determine how many folks are joining us today, we'd like to know how many people are viewing today's webinar with you. If you could please click on your selection on your screen here to submit in just 1 second. The poll should be popping up right now.
Before we start, a few housekeeping items. All attendees should be on mute during today's presentation. However, we ask that you please mute your phones or your computer microphones as well to ensure that we keep a clear line for our presenter. Should you have any questions at any time during today's broadcast, please submit them by using the question box in your GoToMeeting dashboard. We'll have a brief question and answer at the end of our presentation as well, and we'll make every attempt to get all your questions answered. If you have any audio or visual issues during today's presentation, please do not hesitate to let us know using the chat function again on your dashboard or by emailing Chris Williams at cwilliams@awci.org. We'll attempt to resolve any issues that may arise as quickly as possible. Today's program will be recorded and uploaded to the AWCI Media YouTube channel, and all attendees will receive a link to access this and other AWCI recordings about an hour after the program, which will also include a link to our brief follow-up survey. Today's PowerPoint slides may be downloaded by clicking the handouts link on your dashboard. We'd like to extend our thanks to today's sponsor, Dryvit Systems Incorporated. Since Dryvit began 50 years ago, the company has been dedicated to providing quality service coupled with superior exterior cladding solutions for new construction and restoration. With customization options to match any aesthetic, your building can have the look of brick, granite, stone, or metal panel at a fraction of the cost. With design flexibility and energy savings, architects, builders, and owners get an added peace of mind. Dryvit's Tech 21 panelization program offers 3 unique prefabricated panel systems that can be used to provide continuous insulation and a multitude of aesthetic options to practically any building. For more information, please visit dryvit.com.
And now we'd like to welcome today's presenter, Larry White from Applied Restoration Incorporated. Larry's celebrating his 40th year, if you can believe it, in the wall and ceiling industry, and serves as the president and CEO of Applied Restoration Inc., with offices in Seattle and San Diego. Larry's extensive resume of industry involvement includes serving on the board of directors and as secretary for the Northwest Wall and Ceiling Bureau, and as an AWCI board member-elect and chairman of the AWCI Youth Education Committee, Youth Technical Committee, and the Plaster Craft Committee. Larry's also a trustee of the Washington State Cement Masons and Plasterers Pension, Health and Welfare, and Training Trusts. Serving as a member on the ASTM C11 Gypsum and Related Products Committee, he's also an AWCI Youth Smart and Air Barrier Association of America certified executive. Larry worked on his first prefabrication jobs in the 1980s and has worked in most aspects of building envelope construction. Under his direction, ARI has been recognized with 7 Northwest Wall and Ceiling Bureau Regional Awards and 3 AWCI National Excellence in Construction Quality Awards. That's quite an impressive resume. Larry, welcome, and thanks for joining us today.
Thanks, Chris. I'm glad to be here. So I've given a number of presentations over the years, but this is my first time presenting in a webinar. And when I get up in front of a crowd of architects or peers, you'd always want to start out, people say if you get nervous, well, just imagine everybody in the audience in their underwear. Well, it's kind of different. I was thinking about it last night, being on a webinar. For all I know, you all could be in your underwear. Actually, for all you know, I could be in my underwear. Anyway, I just thought I'd bring a little levity to start us off. So I'm going to try to cover as much information as I can. I want to give you guys a feel for prefabrication, how it can kind of affect your business. But I'm going to talk about a little bit about the process and theory of why we're doing prefabrication, a little of the history, which I have some experience in, current uses, how we're using it in new construction, restoration, advantages, disadvantages, and then the future, because we all want to be looking ahead at where we're going. And so with that, let's start with the processes and theories. So I was kind of looking at the restoration aspect of prefabrication. So we talk about prefabrication. IKEA is kind of the king of prefabrication. They engineer parts, they prefabricate things that they fit together. And how do you fit them together? A set of drawings, assemble the prefabricated parts. And even with the same basic engineered parts, they can create many different looks and designs. And that's really what we're doing when we're talking about prefabrication. And we're prefabricating buildings instead of cabinets and furniture, but we're using a set of drawings to assemble prefabricated parts that are engineered to fit together in a very specific manner. And so prefabrication kind of covers all that. Now let's talk a little bit about the history of prefabrication. So I brought this building was actually prefabricated exterior panels. It's in Wilsonville, Oregon, and it has a metal framed panel. They were actually red iron or red painted. They weren't galvanized light gauge metal panels. They were regular exterior gypsum and an eave system on it. This project was paneled with, there's not 4 levels of panels there. There's only 2 levels of panels, the midpoint between the 2nd and 3rd floor. And that, there's basically a joint around there. But each of these sections was 2-story panels. And it's only a 4-story building. A lot of what we've thought about panelization was, you know, it's used on bigger high rises, multi-stories where access is tough. But that doesn't mean that's where it has to be used. You know, this was a big part of the 70s and 80s, was really the advent of panelization like we see it today. We're all kind of thinking, oh, panelization or prefabrication is relatively new to the construction industry. And where this came about was the introduction of lightweight framing, gypsum products, and EIFS products, which at the time were really conducive to panelizing because they created a lightweight architectural panel that could be easily put into place and attached to the building. That was in the 70s and 80s. You know, it was, we didn't have the look at that time of precast concrete, but it was definitely a lot less expensive and a lot easier to do. And I think people don't realize how many buildings around that they drive by that they don't even realize were panelized. And, you know, so that brings us to today. And I've got a little bit of statistic here from the foundation industry, but in 2010, we were using 13% of our projects were using prefabrication. In 2016, that rose to approximately 35% of our projects. And it's rapidly growing. I think if we look at the numbers today, it's becoming a bigger and bigger part. People in construction didn't even think about things like modularization, where they build a whole room with furniture in it and lifted it into a job, off-site construction. So that's a little bit of the history of kind of where we're at in the wall and ceiling industry with panelization and prefabrication, kind of where it came from for us. And I'll let you know that if anybody has any questions, you can get them to Anne-Marie, and I'll take questions throughout the presentation.
Larry, I've got a question for you here. Can you talk a little bit about differentiating between prefabrication and modularization in construction? I know that sometimes there's some confusion between the two.
Yeah. So when we talk about prefabrication can be anything from, like an IKEA, where you've got parts and pieces that are pre-cut and pre-engineered to fit together in a very specific manner, and they could be brought out on site, assembled, and then put up, you know, rather than, so when we talk about stick building, where each individual stud is cut on site, you know, all the layout is all fit together, up to modularization, which is where you're prefabricating a whole room or a module, and so it's all different sizes. It could be prefabricated kits, it could be prefabricated finish panels, it could be whole prefabricated wall panels, it could be load-bearing framing panels, and it's mostly it's off-site. The prefabrication part is done off-site generally, and so that's, you know, like I say, if you assembled a kit for framing and then it was assembled on-site, but that kit was actually made off-site, and you might make 1,000 of the same thing. Same with the panels. The panels can be made off-site, and modularization is really where you're doing a whole module, a whole section of the building in the room. Modularization actually is really most commonly used and has been used a long time in the shipbuilding industry. So they would actually do estate rooms or prefabricated, and then they're lifted into place and set into place on a ship frame. So that's where modularization comes in. So the current uses, what we see a lot of, or most of, is load-bearing pre-frame panels. That's probably, whether it's wood or metal, I think everybody would agree. You know, wood trusses are prefabricated. now we're seeing more, and they could be sheathed or unsheathed, and they come in doing load-bearing framing. In fact, next door to our office, there's a 4-story hotel going up that's all prefabricated load-bearing metal framing, 4 stories right from the ground up. You could get into just doing interior pre-frame panels, which is kind of a newer concept. Talking to another company, and they were talking about, instead of just doing the framed exterior panels or the pre-framed load-bearing panels, they're actually pre-framing interior wall panels, doing the layout, setting a top track up, bringing these panels in, sliding them into the top track, fastening them to the ground, you know, with a deflection head, and they're building off site. It's extremely faster. So that's kind of a newer aspect. You know, we all know about the exterior pre-finished panels, and they may be framed or unframed type of panels. So there's a lot of different choices. We'll look at a couple of those different options here. And then it could be pre-finished components. So maybe it's an architectural feature that's pre-finished in an off-site location, and you bring it out and attach to the building somehow. You know, we're seeing a lot more and more different types of panelizations that aren't even, you know, EIFS, which was real popular in the wall and ceiling bureau, but we're seeing a lot of different panel systems that are actually going up. You know, whether they contain a thin brick or a new brick or other lightweight.
And
so
Larry, oops, sorry, go ahead.
Yeah, no.
How and when do you determine if prefab is the way to go on a specific job? What and who go into the decision-making process? Well,
so when we get into, and we brought up the slide on new construction, but it's really about looking how you can use your abilities or improve your abilities to fit it into the job. You know, a lot of the prefab, it used to be, well, it was pretty straightforward building. You know, we're going to do these panels. They're pretty straightforward on the outside. But with the things we offer today, and let's go to that new construction slide, Anne-Marie. So we used to think a panel job or prefabricated jobs where the panels were just really consistent and they were all the same. And that can be a big part of it. But if you look at this building, I mean, you've got changes in finish and textures, and you've got different bump outs and stuff. And so our ability to prefabricate today is getting more sophisticated. It's getting to the point where we can do more. So I would say, you know, any building can have some prefabricated components. Now, some buildings may be easier, some buildings may be harder to prefabricate, but those buildings, you know, you have to really look at, okay, is the building, like I talked about, that interior pre-framing, you know, is there enough consistency that we could make kits? It's about, part of it's about repetitive, you know, can we get repetitive thing? If you've got a hotel and every suite is pretty much the same, or there's only 5 different suite designs, and you can build them all the same and build, you know, 50 of this one and 50 of this one, it's probably conducive. But if you have, say, a custom built house where everything is very unique, every room, you know, probably isn't conducive to prefabrication. Now, that doesn't mean there isn't something that, you know, some aspect of that you could use for prefabrication. And with the new technology, we're getting more and more options. But I think it's really about the building itself. And I think you could look at and find ways to use a prefabrication model in any construction. Most common is new construction. You know, you've got a design, you want to be looking at it early. And the sooner you can get in the door, maybe it's at the design phase where you can say, hey, Mr. Architect, this job would really be conducive to a prefabrication. You can save time in the schedule. Maybe it's cost. You know, it becomes a VE idea. And so when we look at it, you've got to know your company's capabilities. You've got to decide if the building makes sense. And it doesn't always have to be high rises. You know, I worked on buildings in the 80s where we were panelizing 3-story. We had literally 3-story panels. They were about 35 feet high by about 8 foot wide. They each had a window at each floor, and it was just kind of panel after panel. They were repetitive. And it was actually a Navy dorm in Whidbey Island. And so it's not always economy of scale that makes prefabrication the right choice. Sometimes it's the building design that makes it the right choice. Let's talk. People don't generally think of panelization or prefabrication with restoration because you're dealing with something existing and it's repetitive. And I just want to show you, we've got a little 3-minute video. It's not too long. It's one of my projects we did. We used prefabricated panels to restore an existing building. So let's go ahead and take a minute with this video.
Hold on 1 second there, Larry.
So just a little preface on this video as Anne-Marie gets it started. So this was a building that had these stones embedded, built in the 70s, and they were falling off the top of the building 75 feet to the ground to a sidewalk below. One almost hit a woman walking down the sidewalk. And we looked at a lot of different options to try to encapsulate the rocks so they were protecting the people, and also to give the building a new and modern look. And it took quite a while, but anytime you're ready, Anne-Marie.
Yeah, it's just there was a little hiccup in the delay there, Larry, so it'll just take another seconds as it's downloading. It was ready on the rehearsal earlier. It just has a little technology hiccup. So 1 moment, please.
Okay.
Okay, and I think we got it going now. And can you see that then, Larry?
Yeah, but it's moving really slow. It's not playing normal time. It's like walking through. So we put a liquid barrier over the rocks to basically encapsulate them, keep any future. Well, we pressure washed everything, took anything that was loose off at the time. Then we encapsulated in a liquid barrier that you see there. All the work was done off of swing stages, except this little bit you see on the roof. And there was also a sidewalk canopy that was up in place for 2 years to actually protect the public prior to us actually getting this all engineered and figured out. We attached a lightweight grid system onto the walls. As you can see, the big challenge in this building was we had to measure off of basically in space because there was no real flat surfaces. We had panels, and we'll talk a little bit about this. You don't necessarily have to get into the panelization factory business to become a prefabricator. You know, we actually had these panels were produced in Toronto, Canada. They're a lightweight eaves panel with a structural reinforcing embedded in the back. But everything had to fit. You know, when you're ordering these things from 2,000 miles away, they come in on a truck. You know, you got to get it right the first time. Pre-planning is really one of the most important things you can do in prefabrication. It's all about planning, and it's all about getting those joints right. You know, can you imagine if your panels all of a sudden didn't fit halfway up the building and you're trying to modify at that point? Anyway, that's this is kind of the after. It was pretty amazing transformation. And panels really made it cost effective and really conducive to doing this job. So we started the grid structure while the panels were being made, and then as they came in, they got hung on the building.
Thank you, Larry. Sorry for the little snafu there. Thank you all for your patience while we're working through that. We do have a question for you, Larry. How do you bid prefab work? Are things like component design and construction, transporting components from the plan to the job site and so on factored into the bid? And then also, do you bid prefab versus traditional on-site construction side by side in some cases to show the construction manager what each will cost?
Yeah, so I'd say the answers to both of those is yes. I mean, you have to take into account the prefabrication part. You have to take into account the logistics. You have to, I mean, that's all got to be figured in. And prefabrication might not always be less expensive, but it might be the savings in schedule that really make it benefit the job. You know, and these advantages are where it really can come in. It's speed of schedule, your ability to control quality in a controlled environment. You're working in a controlled environment. You're not dealing with the weather as much, less manpower requirements, and usually, you know, it's easier to have a better safety program, and I'll get more into that. But when you're bidding this stuff, you know, that building, we looked at a lot of different things in that restoration job, and we looked at tearing off the rock, and we did some cost benefit analysis. Like I say, if you can come into a project early and get it designed as prefabrication, hey, this is what we can do. This is what we can do to open your building faster, to you know, control your quality. You know, we've all got manpower issues. Presenting that and getting a chance to work with that up front is the best way to do the prefabrication. But there's also times where, hey, you look at a building and say, this would be and it might be a design. We just had one of these, and it was like, okay, it was a field implied design, and it was a big structure, and everything was pretty consistent. We said, hey, maybe this really would be a better job to panelize it. And so we actually had to bid it per the drawings, but then we created a VE option to do as a panelization. Now that job hasn't been awarded yet, but sometimes you have to be able to do that. And you're going to factor, I can build the panel faster with less manpower, but now I have to handle it. I've got to have semi trucks. I got to have craning, the tie off. All those different factors can come into play. And then, it might not necessarily be a cost savings, but maybe it's like, hey, this thing's going to be constructed in the middle of winter, and I don't have to scaffold and tent the whole outside of this building to get the finish on. Or the fact that you're going to, a lot of times you can't frame an exterior wall until you've got a structure to frame it to. Well, in this case, you can frame the exterior wall and put the finish on, as shown here, well ahead of the structure going up. But to do that, it takes a lot of pre-planning. So you have, like any bid, you have to take in all the things into effect. You have to think about fire rating. How is this building going to require an exterior fire rating, and how is panelization going to fit into that? And sometimes it's innovation. What can I do different? And if you've got a plant and you're up and running, go ahead.
One other question came in. They're asking about what is the maximum radius from the prefab factory where the cost of delivery still makes it possible to competitively prefabricate?
Well, I would say that really kind of depends on the panel. Obviously, bigger, heavier panels are going to be more expensive to truck over a longer distance. I would say, I think a rule of thumb that I've heard before is people used to go like 800 miles, and now they think maybe 400 miles, cost of trucking, cost of gas. Now, we ship panels almost 2,000 miles and out of a different country, but our panels were really pretty lightweight, and we had basically 3 loads of panels instead of maybe 30 loads of panels, and that was 500 plus panels on that building. So I wish there was an easy answer, but the bigger and the more complex the panels, the heavier, the more expensive it's going to be to go longer. So you probably have to analyze each project individually. But it may be, if you sit there and you've got a facility and you've got panels going, you might say, hey, the cost of keeping this factory going by doing another panelization job, even though I'm shipping an extra, 200 miles further than my radius, makes me more competitive. Because if you open up a panel plant and you go to that investment, there's some upfront money, but you can't afford, I'm guessing you're not going to be able to afford to keep a building sitting there running only 3 or 4 months a year and be profitable. So that may be a factor in how you make that decision. Hope that kind of answers that question.
Thanks, Larry. You talked a little bit about that investment in terms of, what question here I have is what was that upfront investment for you guys that you required to enter in the prefab market, and how did Applied Restoration come to the decision to go with a third-party production facility versus that in-house plant on your own property?
Well, for us, it was really about looking at, I didn't feel as a company we were ready at this time to actually invest in a panel plant in that operation. Now, I probably see it down the road, and you could start small and obviously increase depending on what kind of panelization you want to do. but say you wanted to just get into the kit building process, you might invest more up front on a machine. Maybe you want to roll your own studs, or you know, have some prefabricating abilities, that maybe using some more technology, and you might invest in that. Or you might say, hey, I'm going to buy $1 million, or lease a 100,000 square foot warehouse, you know, and you might get into starting a panel plant that's going to cost you $2 or $3 million, get rolling by the time you get an overhead crane. If I looked at this facility in Toronto, which I visited, and they do all kinds of panels, but they had a huge facility. They had 2 overhead cranes in the facility. They had 5 welding stations. They had silos for mixing wet materials. They had a lot of storage and a lot of room to move panels around. And starting a plant like that would be a big investment. But the other thing was they had to keep it moving. They couldn't afford to keep it empty. And so they looked at a pretty big radius and other partner opportunities. But we've seen smaller stuff where you, like I say, you could have maybe a couple thousand square feet. You could pre-do framing kits. Or I know of one company that had a prefabricated job. It was load-bearing light gauge framing, and they had a specific job that was. They went to the locality, and they rented, or they leased a piece of property, a couple acres of a basically gravel lot, and set up their panel plant. I know actually 2 companies that did that, and prefabricated all their walls for a hotel. They weren't on site, they were pretty close. And then sometimes there's opportunities where you could say, hey, we could make these panels on site. I mean, for us, we even look at, I had a job that had all these big architectural foam shapes. We had them pre-cut. Well, we end up in the parking garage of the building, we end up pre-finishing these shapes and then sticking them on the outside. The rest of the work was done on site. But I mean, there's all kinds of opportunities. So an investment could be a lot, or it could just be a little bit.
Thanks, Larry. And before we move on to the advantages of prefab work, I'm going to ask a question that just kind of popped into my head. You talked about having production facilities close to the job site. You've seen some companies that are doing that. Do you foresee a time in the future where the production facility itself could be made modular, so it's transportable, basically disassembled, moved from site to site to make it easier and more cost efficient for a company to have a production facility of their own?
Well, you're thinking kind of really out there right now. Anything's possible, Chris. I mean, we're seeing things. Yeah, the distant future. Maybe you panelize a building that you can move and build your panels in. I don't know. There's probably ways to do that. You know, I think these companies, they rented like where they had some wet work, and as when I say wet work, they were just doing the weather barrier on the building, but they had set up some tents for the wet work. You know, basically part of the land, they set up some of those big tents you can rent. So there you go. There's your, you know, Cirque du Soleil environment.
We'll be retired by that point, but thanks for indulging that one.
So let's talk a little bit about some of the disadvantages of prefabrication that you may have to think about, and maybe I don't want to say disadvantages, but some of the challenges you're going to face that you have to understand as you come down this road if you decide to do prefabrication. And I think the biggest challenge, that would be a better word here, the prefabrication, is it takes a lot of engineering. You know, you're really becoming a design build contractor at that point, because these panels have to be engineered and designed. They have to fit together, and they have to, you know, carry the load of the weight of the finishes on it. Like I say, you have the challenges of fire rating. You know, sometimes you have to think outside of the box. We were actually looking at, and what you'll see in these panels, and you can see them here, and it's real common, especially with the each clad panel, is that the exterior finish gets applied, or the base coat finish gets applied to the edge of the stud. These get put into place, they get caulked. Well, what if it's a fire rated wall and you're fire caulking, but the fire caulking has to be outside at a certain place right next to gypsum? We actually looked at, you know, so how can we innovate there? I looked at some intermescent tape that could be applied to the end of the frame there. So you order the frame, or you attach this intermescent tape to one side of the panel, the next side goes in, you know, you've got your gap there, and then we actually covered that intermescent tape with base coat mesh and then hit it with a torch just to see what it'd do. And it did just what the intermescent was supposed to do. It broke right through that surface and sealed off the cavity there. So that's just something that people might want to think about if you have a fire taping requirement or fire rating requirement, because sometimes the cost of trying to fire rate that and get that passed in code could make, well, maybe the panels don't make sense there if I have to do that. So you have to think about innovation, but it's really in the design. And the other aspect of the design is the extra coordination between the GC and the other subs. So one of the challenges is you're building this off-site, but it gets there and it's got to fit. You know, I can give you an example where there was a real challenge. We didn't do the panel job, but at the time our company had done the sealants. Well, the Palazzo in Las Vegas is 58 stories of panelized system on the exterior, and as they got higher and higher up, the joints got closer and closer to the point where there was really no caulk joint, and that became a real challenge on how to make adjustments there. So you got to make sure that the tolerances that you're working to, you know, that the iron worker has, that the other trades have, the guy pouring the concrete, are within the standard that you have enough tolerance in your panels to be able to fit that building once you get your panels on site or your prefabricated parts. You know, if you prefabricated a bunch of kits and you get in and the concrete beam was set an inch out of place, all these kits you assemble them and they might not fit. So I think that's one of the things that you have to really be cognizant of as you take on prefabrication work. The other thing is additional logistics requirements. You know, sites are getting tighter and tighter today, especially when you're building in a city environment. And so that can make panelization really attractive because you don't necessarily need the room to store materials on site. You're not trying to, like your interior framing and even your exterior framing. I know in buildings that need fireproofing, you know, one of the big challenges when a building's being fireproofed is they don't want all your materials sitting there in their way. So you're kind of last minute stocking. And so the logistics of a panel could be favorable, but it's also, hey, I've got to get them on site, and I've got to have my truck lanes figured out, where my truck's going to sit. And then you also have to have a contingency plan. Hey, I've got to get these panels out, and I'm expecting to put them on the job next month, and the building's not ready. You know, the building falls behind schedule. All of a sudden, you've got all these panels and no place to put them. You know, do you have to go out and rent a temporary storage facility? You know, be upfront with your contractor. If you've got a schedule and he's not meeting it, you know, hey, here's our contingency plan. If I can't put my panels up in order to keep my operation moving, maybe you got another job coming in behind it. You know, you're going to have to find a place to store these panels or pay extra to store these panels until I can get them on site. You probably can't afford to bear that burden of cost. Maybe you can. Maybe you've got enough room, and depending on it, where you could have a week delay, or it's not going to hurt you.
Larry, when you had just mentioned planning and having a contingency plan, what type of internal planning do you all do for developing your contingency plan?
Okay, half of. Can you repeat that?
Yes. So what type of planning do you do to develop your contingency plan for a job, one of your job sites with your panels?
Well, first off, you've got to make sure, especially if you're working with a third-party vendor, that their quality control. That's why I visited the plant. We wanted to make sure what they were going to do was going to meet our standards. What the timing was. You have to have a plan in place for which direction you're going to order the panels. You don't want to get the panels that you're going to put up last before the panels that you need to put up first. So that's all part of the logistics as well. But what we do, like I say, you've got to kind of plan for that. We did have a delay where we got panels in before we were able to get one section of that building ready because of some actual building conditions that we didn't know existed around the second side of the building. But we were able to find some extra space to store it. But we did charge the client that because that delay wasn't caused by us. So, that's really, like I say, it's talk about it ahead of time. Be forthcoming. Hey, if you're not going to meet the schedule, we're going to have a problem. So you got to it's really got to be a team effort. I look at this picture and I liked this picture because it shows you, hey, the site happened to have enough room that they could panelize right on the site there. But quite often, I'm surprised that you've got to coordinate because, hey, maybe they need to dig a trench through the middle of your panel plant, or they want to start paving, or, how's that affect this? Does your setup here, then if there's a delay, affect somebody else? And so all those things have to be taken into account. We just try to be as proactive as possible and set reasonable expectations up front and know your capabilities, know how fast you're going to be able to build these panels.
And Larry, talking about increased coordination with the general contractor, construction manager, when does that start in the process? And do you get involved in the design phase, site work planning, et cetera, to make sure that things lay down in areas are built into the overall plans?
Yeah, you need to get in. The sooner the better, but you have to get into that contractor as soon as possible. As soon as you've got that job, that's got to be step one, is starting the engineering, the logistics all together, and having that plan. And so it takes a lot of pre-planning on your part. One of my old mentors used to say, plan your work and work your plan. And that really is even more conducive to prefabrication, because you're pre-planning your work, and then you've got to make it all fit. And so it really is about pre-planning, and the sooner you can get in and the sooner you can get coordinated. Hopefully you've decided to panelize this building because you were in at the design phase and you convinced them that that panelization was the way to go, and so they have a already preset expectation before you even get to the job. Hopefully, you know, if we're all lucky enough to be able to negotiate work rather than having to come in and bid it. But even if you bid the job and you VE it for prefabrication and they accept that VE, you know, you've got to get them right on top. Okay, maybe you qualify them. Prefabrication, put it in your scope. Prefabrication requires additional coordination between the general contractor. You know, we put those requirements in your scope. We require a logistics plan. We require higher tolerances, or maybe you don't. Maybe depending on the building, you don't need as high tolerances, you know. But you should be talking about that, because you should be talking about schedule right from the start, because that's really what you're bringing to the table. There. So let's see. Talk about a bit about the advantage and the disadvantage. Let's talk a little bit about the future. So, you know, the future in the construction industry is technology, and the future is now. I brought this picture back up. I showed you this in the first slide, because this was done in the 70s. You know, when this building was built, I was going to college, actually, and at the college they had a computer that took punch cards. You know, laptops were not even, personal computers and laptops were not even heard of. This building was panelized, engineered, and built using hand-drawn drawings. And I know the owner of this company. He just recently retired a year or so ago, Dick Cron, that panelized this job. And you know, his big thing about panelization was the pre-planning and the engineering and making sure everything fit. You know, and to think about how they did that back then, and think about today, all the things we have in our pocket that can help us do prefabrication even better, from CAD and BIM. You know, we can GPS, digital mapping, 3D modeling. You know, you can see how things are going to fit together pretty accurately before the building ever breaks ground. Virtual and augmented reality. You could actually do a training in virtual reality on how these guys are going to assemble a panel. You could pre-assemble one through virtual reality. Think about the planning you could do. Think about how efficient you could make your people. And we're going to see more and more robotics. One of the big challenges that we have in construction today is lack of skilled manpower. So prefabrication takes some of that skilled manpower need away. So maybe, you know, you can build this exterior with 6 guys in a panel plant rather than 20 guys on site. You know, use of robotics, or even prefabricated components today. You can get sheathing with weather barrier on it, or as part of its core already. You know, you can, you know, we may see times where your panel plant, well, we're seeing panel plants today. I can tell you right now that Dick Cron in the 70s and 80s, when he started panelizing, he wasn't thinking about having his old cold rolled forming machine for his studs in his plant. But that's a reality today. Some of the panelizers are actually rolling their own studs, and computer systems are figuring out the size and shape. You know, you may see automated systems that are moving your panels around inside of your shop. You may see more of that stuff that comes into on-site. You may be using augmented reality to actually make sure panels are going to fit. I think that the future is it's unlimited right now, and it can just make construction better and better.
Larry, you mentioned robotics involved here as in VR and AR. Do you foresee a time down the road again, put my futuristic glasses on, when the component production process becomes entirely automated, robotic, or is there always going to be a need, especially from a quality control standpoint, to have hands on the panel while it's being built?
Well, I mean, if you look at the automotive industry, they still have, even though they have robotics, they still have employees in their factories. There might not be as many as they're used to. So I don't think it'll, really take it completely away. And I don't think robotics are going to be conducive to hanging the panels or installing them. Maybe I'm wrong. Who knows what the future will bring? But I think that it's like anything else. As things get cheaper, we start to use them more. And I think robotics are going to be the same thing. Robotics first came out, multi-billion-dollar companies like GM and those companies were the first to use them, BMW and Mercedes. Now we're seeing robotics in more and more industries. The price has come down. And I think it's probably the same thing we're going to see here. Those technologies, who imagined a self-driving car? And who imagined a self-building building? I don't know that we're going to get to that point, but things are changing in how the whole world works. So the possibilities, like I say, are limitless, and I think we will see more and more robotics coming into our industry.
Thanks, Larry. The safety guy in me is going to come out here. I want to circle back to some of the advantages you mentioned earlier about prefab work, and one of them was in terms of safety and health. How does prefab affect your safety and health program? Does the fact that the components are assembled, the panels are assembled in a manufacturing setting contribute to overall risk reduction, or are there new risk factors that come into play on the installation side that kind of balance that out?
Well, I wouldn't say it kind of balances that out. Construction in general is a pretty risky business. We all know that. I would say that safety is a bigger issue in construction than a lot of different industries. But at the same time, we're all used to safety on site. It's a big deal. We need to be safe. You've got a lot of different conditions, and really, what the factory allows you to do is not only control the environment, but control your safety. You don't have as much risk. When you're in a panel plant, you don't have, your workers aren't, 10 stories up on the outside of a cable or tied off. They're not threatened to step in a hole or walk on uneven ground walking in and out of a site. There's usually no ditches in a panel plant. So you've got some safety factor there, but there's probably other safety concerns you have to worry about. Moving these big panels around is a little different in a factory than moving a stud around on a job, and putting a whole panel up. But you're using less hours. If you're not using a scaffold, you don't have to worry about fall protection on a scaffold. But you do have to worry about, guys hanging a panel on the outside of a building in maybe an exposed condition where they've got to be tied off. So you have to think about that, but we have to think about that all the time. Like I say, if I was doing the outside of the building and I had 25 guys out there on scaffold, well, I've got a safety concern for 25 guys. If I've got 6 guys hanging panels, I've got a safety concern for 6 guys. It's easier to manage the safety for 6 guys on the site. And like I say, in major commercial construction, we all know that safety is number one, keeping our people safe.
And before we wrap up, Larry, I want to get to our audience questions here. Earlier, you discussed interior panels that were slid into place with top tracks pre-installed. Are those panels also pre-drywalled prior to installation?
Well, in this one example, I wasn't sure, but I don't think they were. But that doesn't mean you couldn't do one side, you know. Like I say, it's innovation. It was something that new that another peer of mine was doing, had talked about doing, and it was kind of a first experiment for them.
Mm.
But I don't know, you might get to the point where you got it pre-done. Maybe you've taped the flats on it too, on drywall on one side, and tape the flats, and you do the inside of the rooms or the outside. You know, it may get to the point where you're talking more about modular, where the electrician is coming into your plant and he's pre-running his conduit in your framed wall and presetting his electrical boxes. You know, but you also have to think about, the more you're doing off-site is special inspections, arranging inspections, what inspections you're going to need off-site versus what inspections you're going to need on-site. So that all has to be factored in. And that'll be a cost thing. You know, does it make sense to do it? I think if you have, you know, putting weather barrier on an exterior panel nowadays, well, you also have to think about air barriers. So if you're going to panelize or prefabricate, how does that affect, you know, getting an air barrier today? Because it's not just, you know, putting sheathing up, and how do those integrate? How are you going to seal? How are you going to flash? What do you need for drainage? How are you meeting code? But those are all, we have the capability of doing all those things today. You just have to address them as part of your approach to prefabrication.
Larry, thanks for taking the time out of your schedule today to sit down with us and talk a little bit about prefabrication and help us better understand its growing role in construction, and also some of the future opportunities that we're going to have with it. Thank you very much for that.
You're welcome. Yeah, go ahead.
Oh, I was just going to say thank you also, Larry.
Okay, so this webinar is a little different. Like, I can't see, you might all be sleeping by now in your underwear. Anyway, enjoy the day. Thank you.
Thank you. And on behalf of AWCI, we'd like to thank everyone for joining us for today's AWCI Media Online Learning Series program. We would also like to thank Dryvit Systems Incorporated for their generous support of our webinar this afternoon. As a reminder, the program was recorded, and you'll receive a link to AWCI's online program library, as well as a link to a brief post-event survey following the conclusion of today's broadcast. In addition, we also have some great resources available through the Foundation of the Wall and Ceiling Industry, which you may access by visiting our website. And our next AWCI Media Online Learning Series program, Creating a Purpose-Driven Culture, will take place in next January 2020. So be on the lookout for an email with details on how to register next month. And thanks again, and have a productive day.